This is our pre-lab video for lab 17, which is the molar mass of a gas. The purpose of this lab is to find the molar mass of a gas through some lab measurements. Now, the reason why you might be interested in finding the molar mass of a gas is because if you're trying to identify a gas, molar mass is one way that you can exclude some compounds and narrow it down. For example, if we were trying to figure out which gas we were working with, we could make some measurements, calculate the molar mass, and then we could use that molar mass to identify which gas it was by matching the molar mass to a certain one. So if we did a calculation and we found out that our molar mass was something around 16, we would know that it was methane. When we look at units of molar mass, we see that we would take grams and we would divide it by moles. And for a gas, the grams is something that you can measure using a scale or a balance. But we don't have an instrument that directly measures moles. But for a gas, if we know the ideal gas law, we can measure pressure, volume, and temperature, and we can calculate the number of moles. When you put these two things together, grams on top and moles on the bottom, you get an equation that looks like this. Molar mass equals grams times R times T over pressure times volume. Now, if you've read your pre-lab, you might recognize this as equation 4. It's written a little bit differently. Instead of grams, mass is written in here. And so equation 4 is actually written as the molar mass equals mass divided by pressure and volume times RT. But these two things are really the same. Equation 4 is great as long as we can measure the mass, we can measure the pressure, we can measure the volume, and we can measure the temperature, we can find the molar mass. But that's a lot of measurements to make. So this lab also includes another way to calculate the molar mass, and I'd like to compare the methods. So the first method we talked about is using equation 4, which needs a pressure, volume, and temperature and mass measurement for the gas that you're trying to study. But there's also a different method that we can use, and it's a method that uses the relative molar masses. So you're comparing your unknown to a known gas. And this is actually equation 7. Equation 7 says that the ratio of molar masses between a known gas and an unknown gas, so mm is molar mass, is equal to the ratio of their measured masses. So little m here is the mass on a scale that we would measure. What's nice about equation 7 is that we only need to make two measurements, the mass of our known gas and the mass of our unknown gas. So we only need a mass measurement of a known gas and a mass measurement of our unknown. So that's only two measurements that we need to make. But it also means that you need a known gas, something that's well studied. So there's pros and cons to each of these methods. If we're using equation 4, the pros are that it's a direct measurement. But the con is that there are lots of measurements that you need to make. For equation 7, the pros are there are just a few measurements, just 2 masses. But the con is that you need to know about another gas, our known gas. In this lab, you'll be given data so that you can calculate the molar mass of a gas using both equations. And just a reminder, when you're doing your calculations, the mm's are molar masses, and the little m's are a measured mass. When you're working with equation 7, it doesn't matter whether you make the 1's your unknown or you make the 2's your unknown. But one way that it might be easier to write it is if I'm going to make the 1's my unknown, I might write it like this. And then the known gas that we're going to be using is air. Like this. Now let's review what kind of measurements we need to make to be able to do these calculations. When I'm working with equation 4 here, the kinds of things I'll need to be able to measure is the mass of my unknown gas. I'll need to be able to measure the pressure. I'll need to be able to measure the volume. And these are all of my unknown. And I'll need to be able to measure the temperature. When I'm working with equation 7, I just need to know the mass of my unknown, the mass of air. And I also need to know the molar mass of air, but that one isn't a measurement, it's given in the prelab. Now this is all data that you'd be able to collect in class or data that you would be given. And let's talk about how you would measure these things if you were taking the data yourself. Now I have the measurements that I need to take over here. And I'd like to actually start with how we would measure pressure. As long as we're doing this experiment in a room where the pressure isn't changing very much, which is an atmosphere like what we have, and as long as we collect the gas at the same pressure as the pressure around us, which is what we're going to do, the pressure of the gas is going to be equal to the pressure of the room, which is what we call barometric pressure. Now we can measure barometric pressure by using a barometer. And we have one of those in our lab. But we could also look up a barometric pressure that somebody else has measured for us. So as long as we can do one of these two things, we can measure the pressure of the gas. The next one that I want to talk about is the volume of a gas. Finding the volume of a gas is relatively easy because gases expand to take up all the room in any container you put them in. The container that we're going to use is a syringe that looks like this, and it has a plunger that you can pull, you can push in, or you can pull that plunger out. So this is what an empty one would look like. And this would be one where you had, this guy here would be where you had pulled the plunger out and it would be filled with gas. Now the gas is only going to stay in there as long as you make sure you put the cap on. I've actually taken a couple pictures of what our syringes would look like. This is when it's empty, and this is when it is filled. Now to find an actual measurement for volume, we could read the syringe and figure out what volume this was. But our lab techs were really nice. And if you focus in on this part of the syringe, you'll see that there's a nail going through right here. And why that nail is there is that it fixes the volume. It fixes this volume at 60 milliliters, which is 0.0600 liters. And that's why all of our volumes for our measurements are going to be 60 milliliters, 0.0600 liters, because we used this nail to stabilize the volume. You can't push or pull the plunger out anymore. And that's how we're going to know the volume of our gas. It is a fixed volume at 60 milliliters. The temperature is our next one. Temperature is going to be relatively easy. The temperature of the gas is going to be the same as room temperature. So as long as we take the temperature of the room, we'll have the temperature of our gas. The last one that we have to measure is the mass of the gas. And this seems like it would be relatively easy. We have balances that we can measure mass with, but things get a little bit tricky when you're trying to measure the mass of a gas. The first problem is that gases are so light that even if you have 60 milliliters of them, they just don't weigh that much, and so our changes in mass aren't going to be very significant, and there can be a lot of error associated with that. The error is compounded by the fact that there are some buoyancy issues. And to talk about buoyancy, I want to show you some different situations. So I'm going to draw out some syringes that are filled and empty, and we're going to look at the relative masses. Before I show the actual masses, I want to talk about what each one of these syringes is that I drew. The first one here is empty. Okay? I pushed the plunger in, I put the cap on, and I took the mass. And the mass was 39.0498. The second one I filled with air, and you can see that right here I have my little nail pushed in there so that I know that the volume is 60 milliliters. I filled it with air, and I put the cap on. I want to skip to the last one real quick. This one I filled with an unknown gas, and it has my nail in there, so I know the volume is 60 milliliters, and I also put the cap on. And then this middle open one, this is a syringe in which I kept it closed. I put the cap on, and then I pulled the plunger out so that the inside was not filled with air or any unknown gas. It's actually filled with vacuum. So there's just empty space in this container. The reason why it's not imploding is because of the integrity of the plastic around it. Now I've added the masses of each one of these syringes, and some kind of surprising things come up. The first thing that I want to look at is comparing the empty and the vacuum together. Now you would think that these would be the same because they both do not contain any gas on the inside of them. They're both technically empty, and so you would think that they would have the same mass, but you can see that they aren't. They actually differ one place past the decimal. Now the difference between these two has to do with the idea of apparent mass. This one has the higher apparent mass, what the mass appears to be. and this one has the lower apparent mass. And that's true because their densities are different. Density is the ratio of mass to volume, and they technically both have the same actual mass. I know that the apparent masses are different, but their actual masses are the same. The difference between them is that this one has the same mass, but its volume is actually a little bit higher than this one. The volume's a little bit lower, and that's because the plunger is pulled out of one and pushed into the other. So this one that has the higher volume because the plunger has been pulled out has a lower density, and because it has a lower density, it means that it's actually buoyant in the air around it. Now, when we say the word buoyant, it basically means that the air around this syringe is pushing it up. It's kind of levitating. It's less dense, so it floats to the top. And because it floats to the top, it appears to be lower mass than something that is not as buoyant. Now, these buoyance effects are going to have effects on all of our syringes. And because the syringes that we're most interested in are the ones that have gas filled in them, we need to be able to compare them to a syringe that has the same volume. If we're trying to find the mass of the unknown gas, we could take the difference between these two. So what we're doing is we're taking the mass of our unknown gas in syringe and cap and nail, and we're subtracting out the mass of the syringe, the cap, and the nail. The difference would be the mass of the unknown. But that's not true because they don't have the same volume. This one has a lower volume, and this one has a higher volume. So they're affected by buoyancy differently. And that means that the difference between them is not the mass of the unknown. The mass of the unknown is found by taking the difference between two things that have the same volume. So these two have the same volume, and so they're affected by buoyancy the same way, and the difference between these equals the mass of the unknown. If we want to find the mass of air, we would take the difference between these two. And we can say that's true because, again, these two have the same volume and are affected by buoyancy the same way. And when we reflect back on it, our empty syringe, we don't actually use that mass for any calculation because it doesn't have the same volume as the other ones we're interested in, and it's not affected by buoyancy the same way, and so the difference in masses aren't accurate. So now we know how we would find the mass, the pressure, the volume, and the temperature, and we can use that information to either use equation 7 or equation 4, which are two different ways to find the molar mass of the gas. Equation 7, you would just need the masses. Equation 4, you need to measure the mass, pressure, volume, and temperature. Now from here, you're going to use data you collected in class or data that was provided to you to find the molar mass of natural gas, which is our lab gas, the gas that is pumped into our labs. You're going to do it both by using equation 7 and equation 4, and then the results section is going to ask you to compare them. Which one do you think is more accurate? Then you're going to use your data and equation 4 to find the molar mass of an unknown gas. And then you're going to use that molar mass to pick from a selection of gases to find the identity of your unknown. In this pre-lab video, we've talked about what equations we will use. We've talked about what variables and data we need to collect. We talked about how to use that data to calculate a molar mass. And then we talked about how you're going to use that molar mass to make your unknown gas into a known gas.